Hey geologists. We are now going to talk about how metamorphic rocks are classified. So we're going to talk about their texture. I want you to think back real quick to the graphic organizer that you either did with Mrs. Schaefer or myself. We talked about how rocks are classified by their color, mineral composition, and texture. And the texture for this one, there was three little box like side things that came off of texture. We've talked about the grain size, so no visible grain, fine grain, or coarse grain. We've talked about grain shape, so we've talked about rounded or jagged. And then the last one we're going to talk about is banded or non-banded. And in this case, it's going to be foliated or non-foliated. So let's go ahead and start talking about metamorphic rocks and their classifications. While metamorphic rocks are forming, intense heat changes the size and shape of the grains or mineral crystals in the rock. Extreme pressure squeezes rocks so that the mineral grains line up in flat, parallel layers. Geologists classify metamorphic rocks according to the arrangement of the grains making up the rocks. So let's include that before we even go any farther. I've got my notes started. And geologists classify metamorphic rocks by the arrangement of the grains making up the rocks. By the arrangement of the grains making up the rock. So, let's dig deeper. First one we're going to talk about is foliated rocks. So metamorphic rocks that have their grains arranged in either parallel layers or bands are said to be foliated. Foliated describes the thin, flat layering found in most metamorphic rocks. So, let's type in foliated rocks. And it told us, the text told us, if I can go over, the text told us that metamorphic rocks that have their grains arranged in either parallel layers or bands. So metamorphic rocks that have their grains arranged in either parallel layers or bands. And then I wanted to talk about foliated, just so we define what foliated is. And I said that it describes a thin, flat layering found in most metamorphic rocks. Describes the thin, flat layering in most metamorphic rocks. Because we talked about foliated and non-foliated, but to understand what non-foliated and foliated are, we have to talk about what foliated is in the first place. So let's keep going. For instance, the crystals in granite can be flattened to create the foliated texture of gneiss. I know it looks like gneiss, but it's gneiss. Slate is also a common foliated rock. Heat and pressure change the sedimentary rock shale into slate. Slate is basically a denser, more compact version of shale. But as shale changes into slate, the mineral composition of the shale can change. So let's make sure we put our examples here. So the examples it gave us were gneiss and slate are two common ones. So then let's move on to non-foliated, and then there's something else that we need to talk about. Non-foliated first. Some metamorphic rocks are non-foliated. The mineral grains in these rocks are arranged randomly. So, non-foliated rocks are metamorphic rocks that have grains that are arranged randomly. Marble and quartzite are metamorphic rocks that have a non-foliated texture. Quartzite forms out of quartz sandstone. The weakly cemented quartz particles in the sandstone recrystallize to form quartzite, which is extremely hard. Quartzite looks smoother than sandstone, as shown in Figure 2. Finally, marble usually forms when limestone is subjected to heat and pressure deep beneath the surface. So then, the examples that this one gave us were marble and quartzite. So there's one other thing that we need to talk about that's kind of not specifically stated in your book, but it's still really, really important stuff. And it's to talk about parent rocks. And I'm going to kind of draw your attention back to the text first. So here it talks about the crystals in granite. Can I highlight this? Yeah, where's my highlighter at? Ha, highlighting tool. Ooh, that was bad. Undo. Is there an undo button? Well, we'll just go like this. This will work. So the crystals in granite can be flattened to create the foliated texture of gneiss. Oh, stupid thing. Hide highlights, whatever. Okay, the crystals in granite can be flattened to create the foliated texture of gneiss. So, gneiss forms from granite. And if we keep going, it says, heat and pressure change the sedimentary rock shale into slate. So, looking at that, what do you think a parent rock might be? Well, if you think about it, you come from your parents, right? So a parent rock is the beginning form of a metamorphic rock. A metamorphic rock comes from a parent rock. So in this case, granite is the parent rock for gneiss. Shale is the parent rock for slate. And then moving down here, sandstone is the parent rock for quartzite, and limestone is the parent rock for marble. So it's important that you know these things, because in this next lab I'm going to ask you to see if you can identify what the parent rocks are for different metamorphic rocks. It's really important that we know where a metamorphic rock started from, because it kind of tells us a little bit about the rock itself. So parent rocks are the rocks from which a metamorphic rock forms. And so examples was granite is the parent rock of gneiss. I'm just going to keep listing them. Shale is the parent rock of slate. Sandstone is the parent rock of quartzite. And limestone is the parent rock of marble. So parent rocks are important. It tells us where they come from. Same thing as you. Looking at your parents, you can kind of see where you came from. The characteristic that you have, these rocks are going to have somewhat similar ones. But remember, from the book, it said, where did it go? But as shale changes into slate, the mineral composition of the shale can change. So things can change from when you move from parent rock to metamorphic rock, but it kind of gives you an idea of where they started. So, and then I'm just going to move down here so you can kind of see this figure then before you go. So we have granite, when you add heat and pressure, changes to gneiss. When you have quartzite, heat and pressure changes, or sandstone has heat and pressure, changes into quartzite. Back and forth, back and forth. So, on that note, good luck, guys!